So we're looking at that number 10, and I want you to just look at it, and on the back, let me see what number 10 is, just in case somebody doesn't have their worksheet. We're looking at the alternating series. Sum goes from 0 to infinity, negative 1 to the n over n plus 1 factorial. I'm 1,010% convinced it converges, but it's not multiple choice. So what test am I going to run? For sure, because I have a viable alternator there. So the AST, what do you start doing to perform it? You take a limit. Yep. So we're going to take a limit as n approaches infinity of the rule of sequence without the alternator. So 1 over n plus 1 factorial. That is just standardly known to be 0. You don't have to do anything. I mean, it's common knowledge. So we'll just equals 0. So we're immediately going to write a therefore. Therefore, the series, we're going to do this one really good, converges, right, by the what? AST. Furthermore,
Can you just say, therefore, S converges?
if you called it S equals, anytime you use a variable, it better be 100% clear to the reader what your variable represents. So I'd be careful with that. I would really be, I'm okay with some abbreviations, even like DCT, LCT, AST, but once you get to the actual AP test and we start practicing, I'm going to advise you to write them out. I have read one for the, I think it was the IVT, where I couldn't read their letters. So if they had written intermediate value theorem, I think I could have picked that out, but when there are just 3 letters there, and I'm like, so I would write it out, but not today. All right, we'll be super thorough, but not that thorough. You can write by the AST. All right, so also, the series, or furthermore, it converges, or S converges, if you've defined it as S, absolutely, or conditionally. Absolutely. Now this one, it's so obvious that this wouldn't be one you have to explain because there's really nothing to compare it to, right? It converges without the alternator. Maybe you can just write that, or you can write the absolute value of a sub n, but it converges without the alternator, and there's no really thing we're comparing it to. There is going to be a ratio test that would definitively show it, but it wouldn't be used on one like this because it's so obvious. Yes.
Can you say, like, furthermore, the way out, like, the series, like, 1 over?
Yes, yes, perfect. It converges absolutely. Now, because it's an alternating series, we're also going to add to this. We're going to get ourselves an error bound, and we're going to find an interval in which we're 100% confident the sum falls. I don't know what it is, but we're going to take out our calculators for a second, and we're just going to go kind of see in what vicinity it should fall in by using our math 0. So I'm going to have you take out your calculator. You'll need it today for all the error. All right, so which is kind of silly because the calculator now has math 0, so yeah, but we're going to go plug it in. Factorial, they told me last hour, was wigging out. I usually put in 999. Most of the kids last hour said their calculator only handled it up to 50. And then it said overflow, so let's just do a 50 just so you can see. Even we're not even getting to infinity, but factorial is so small that basically you're adding nothing after that, or very, very, very little. So just a 50 should give us a pretty accurate idea. And you guys can go ahead and I hope it handles 50. I'm not sure. That's what they said last hour. I tried a 99 and it overflowed. Did yours overflow? They were messing around with it last hour and they said 50 works, so let's just try it. The Inspires are a little bit better with that.
Yeah, I should change to it.
Oh wait, is that one gonna work or is that
How
the
do you
number
use factorial?
Can math probability number 4. The question was, how do I do factorial? So if
Wait,
you
how do I
listen to
figure
this.
out yours, Ashley?
Can I see yours, Ashley, since your Inspire did it to 99, so I'll get the most accurate one? All right, so he's got a .632120. Yours is probably still pretty close to that at 50, am I right? Just as it goes to 0, yeah, I don't know when, but look at how many decimal places the Inspire goes out to, like, I could keep going. Eventually, it might veer off, right? So let's just go ahead and above that one, write the first, let's say, 7 digits of that, and we'll come back to it at the end of the notes. So you're going to find a window that number is going to be in, all right? And we'll go to the notes. So the first thing I want you to do in the notes actually is we're going to do a little play the prices right here. So I blocked out the actual price of this 80-inch television. For each person that guesses, all right, I'm going to say something and it's going to cause you to refine your guess. All right, I got to remember what the actual price was. All right, I have to do a little math here. All right, so I'm going to start with Megan. What's your guess for the price of that television? She is within 1,000 of the actual price. Go ahead and guess.
2,600.
He's more than her away from it. You guys have obviously never bought televisions lately. I actually Googled 80-inch TV and this is what popped up. So this is current. So yours is over hers. Hers was within 1,000 of the correct price. So you guys should be thinking about what I'm saying about their errors. Elizabeth, what's your guess? She is under $1,000 from the actual price. And she guessed 1,300. What's your guess? Okay, his guess is 1,000. All right, he's within about 600 of the actual price. He is no more than 600 off. You know, and I might be stretching in and I'm trying to get you to squeeze in, but he's no more than 600 off of the price of the actual TV. What do you think it is, Kai?
1,200.
Oops, she went up. Why should that have bugged you guys? Because we were, right, we're getting closer with the 1,000. Okay, what's your guess? Okay, we are now within, let's just say $500 of the actual price. 800 was within 500 of the actual price.
I'm gonna go 435.
Ooh, he is within $50 of the actual price at $435. He got a lot closer to the actual sum of this series, so I'm tightening up my error bounds. I'm saying he is no more
My guess was 40.
no more than $50 off. Now you don't know if he's over 50 or under 50, do you?
No.
See what I mean? You don't know that. So it's actually like the absolute value of the difference between the actual price and this guess. So I'm going to talk because you actually finally got close enough where I can start talking about notation. So his guess of 435, right? Minus the actual value, or vice versa, their difference in absolute value. What did I say? He was in what? 50. You don't know if he's 50 over, 50 under, and it's not exactly 50. I said under 50. All right? So that's going to allow you to guess a little better.
480.
Now, she went further away and over my upper bound from him. So still, he was within 50 at 435, right? She went the wrong way. She went over my upper bound.
Upper bound would have been 485.
That's what she said, 485. She's on it. But
399.
you are now under the price, and you're about. Are you closer? You're very. Eli was still closer, so I'm going to take Eli's 435. Are you ready? Eli's 435, and you're 399. His was closer, and I'm going to tell you I'm going to refine my window for him. I said less than $50, right? He's less than 30 in error. He is off by less than $30, and he's closer than your guess of $3.99. What do you think? Yep.
420.
Okay. Now, here, okay. 420 is the closest so far. So now let's talk about what the possible price of the television could be. The difference between the correct answer and our last guess of $420 is 10. You have a 50-50 chance now of knowing the cost of the 10. And you should know which one it is because somebody he clicked it because he's the one who kind of struck on a very close answer, and he's combining it with my answer to, I think, Golden, to realize that he shouldn't go up the $10. What did you do? Went down the $10 because you had enough information to know it's not up, it's down from there. The actual price of the TV was $410. I hope it was. I couldn't remember if it was $410 or $420. Oh shoot! I thought it was $410. When I wrote it down, I'm like, I think it was $410 when I blocked it off, but $410 was the one I was getting you. Well, so much for that, right? But let's talk about what we were doing. We were going, and I was telling you you're within this amount, but you didn't know if you were over or you were under, correct? And when I gave you such a wide variety, when she was so far off, it was really hard to make a guess when I'm like, well, she's within 2,000 of that. And he's like, well, he guessed more, because I'm like, what? You know what I mean? Is it more? So you see how it was very, very off until we started fine-tuning the error, and then we got one that was, I was like, ooh, you're close, right? And I told you he was within $50, but you still didn't know if he was 50 too high or 50 too low, correct? But then Golden went way lower, and he was more off, and so we were kind of shimmying back and forth, and you were able to actually get really close to the actual cost, which, yeah, sorry about that, but had I had it on there right. So I want to talk about that concept of error first before we go show you the alternating series error. So what I want you to do is open your notes to this page, and don't write anything down yet, but I want to talk about notation and the price of that TV. All right, so when you see the notation and you see an alternating series, and it's, I'm waiting for I've got the spinning wheel of doom, and you see this capital S with no subscript, that's the cost of the TV. That's $410, but you didn't know what it was. Does that make sense? Your guesses were what we call S sub n. You're like, I'm just going to do a finite guess, and I'm just going to say what it is. Last hour I did a car, and it was $15,000, and somebody guessed exactly 15. I'm like, well, this isn't going to work because there's no error. I was like, dang, Hannah. Anyway, so the difference between these, but you don't know if we're too high or too low. So what do you always see in the notation around this? This is actually our math notation for your error. It is the amount off you are exactly. Does that make sense? So when we talk about the distance between the actual sum and our guess, which is going to be called a partial sum, when we take the absolute value, you didn't know, Eli figured it out kind of through deduction of the next guesses that he was 10 too high. But he didn't know that originally. You know, there had to be another one to help him sort that out. So you're going to either be too high or too low when it's alternating, because it's going up and it's going down, and then it's going up and then it's going down, and it kind of depends, right? It's going to be kind of pinging around. And so this right here is going to be considered my error. Does that make sense? Which is going to be the most off I could be, and we call that the rest of the terms, or the rest of the money that I didn't include. It's the remainder, though, after the first n terms. Does that make sense? What I'm going to do is show you that it's always got to be less than or equal to a certain number. All right, and that number is going to be what we call an error bound. It means once I said $10, you knew you could go up 10 or down 10, right? So once you know what I'm going to put right here, you know that this guy, you're going to either go up it or down it to figure out where the sum must reside. Does that make sense with the money? I think it helped last hour. So we're going to take a known, convergent, alternating series. Let's just do n squared. Let's go and go from 1 to infinity. I want it to start at 1, though, so I'm going to adjust the count to an n. I don't want my alternating series to start off with a negative. All right? So this guy right here is a known convergent, absolutely convergent, alternating series. Why is it absolute? Awesome. Yeah, you guys got that down. So it's a P series with, in the absence of the alternator, P equal 2 greater than 1. So I totally would conclude that this guy, but that was yesterday's stuff. It's an absolutely converging alternating series. Perfect. But what is it? I don't know. We're going to call it S because it converges. S is a number. It's a number we could get if we could just get out to infinity. So I'm like, I don't know what it is, so I'm going to start writing it out. All right, so I'm going to say S equals, and I'm going to just start generating terms in this sequence just by hand. When I put in a 1, I get a 1. When I put in a 2, it'll alternate, and it'd be 1/4. And then plus 1/9, and then minus, we're going to take it out a ways, so give yourself some real estate on the right-hand side of your paper, right? 1/36. We're going to go to 81, worked well last hour, so I'm going to 49 minus 1/64 plus 1/81 minus dot 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 plus dot dot dot, alternating all the way on out to infinity, but eventually I'm going to be adding nothing and it'll end. That should make sense to you, correct? It's going to go to 0 fast enough where eventually it's going to settle and I can't get past a certain number. What I'm going to do is say I don't know S. All right, so we're going to start with a guess. It's not going to be a very good guess because I'm going to truncate this off right here. I'm just going to use the first 4 terms. Well, that's not going to be very good. Look at all that other stuff, but it actually is pretty decent, even though I only went out to 4. But this would be kind of like when Megan's first guess. I'm like, well, we could refine that a little bit, but I'll go with it, right? So let's go take a look at this. We're going to go figure out what this is. This would be called S sub what? But in particular, for the first 4 terms, that was a little ambiguous last hour. They were like, well, my count started at 0, so don't I go on? I'm like, nope. Whatever number you wrote down when you put a 0 in, that's S sub 1. And then it plus the next one is S sub 2, even though you're putting in n equals 1. So they were a little like, a couple of them were like, that was messing with their head. But just think about that. It's the sum of the first 4 terms, whatever they might be when you list them out. That'll clear up the count issue. All right. Over here is what we call the remainder after the first 4 terms. That bugs some people too because they would love to call that R sub what? Or R sub 5. It's not. Those match. It's what's left after your guess. Okay, so what's left after 4 terms? If you went to the elk time, you understand that that's the 5th term and you're to the right of it. Yes, we kind of talked about that, but that's not today's discussion. What'd you say? Yes. All right, now let's go take a look at what I'm going to do with this R sub 4. I don't know it. If I knew it, I wouldn't have an error and I'd know this exactly. And I would have known the exact price of the car right now, right? Because I don't have any error. I know exactly if I said to Megan right off the bat, and she said $2,000, and I said, well, you're off by 600, and I told her the exact amount. Your next guess is going to be right, because it can't go negative, so you would have known that we got it, right? Anyway, let's go take a look at this guy. I'm going to rewrite this because I don't know what it is, but I'm going to overshoot it. It's called like a upper bound. I'm going to tell you you're less than that away from the TV. All right, I said 50 at first to Eli. He was actually, his first guess was 435. He was actually only off by $25. But I said 50. I overshot it to squeeze. Yeah. Oh, there you go. Yes. So let's go take a look at what this is. And it involves some rewriting here. I'm going to have you put a minus here. And again, this isn't a proof. The full proof is in your Schoology folder, like a professor doing a full proof with A's and B's and sub-ends. If you're interested in that, it's linked in there. This is actually like an exploration, so you can see it with numbers. All right. So this would be minus 1/49. Does that make sense in your head why I haven't altered the, I guess, magnitude of the, right? If you distribute this in, I'm still minus 136, still plus 1/49. I'm going to do the same thing with the next pair, and on out to infinity, I'm going to continue to write it as subtracting. Now watch. This should make sense. Is this piece right here positive or negative? Positive. Is this piece I'm subtracting positive or negative? And all the way on out, I'll keep subtracting stuff from 1/25. Does that make sense? So do you see how this guy right here is actually a really safe upper bound because I'm actually going to be subtracting on out to infinity. Now we talk about this in the next page. They call this A sub n plus 1, but I always think if you can think of it in more layman's terms, like low d high minus high d low, you don't have to remember f prime g of g of blah, blah, blah. It is the first unused term. Because this was a plus, I actually know the actual sum is higher than this. Does that make sense? If it had been a minus, I'd know it was what? Lower than that. So a lot of times we'll see absolute value of the first unused term. Because if I were to use S sub 932 and started my count at 4, you wouldn't want to have to. So a lot of times we'll just throw that in absolute value so it doesn't matter if it ended on a positive or negative. But this is actually the first unused term, which I could have just said, guess what, guys, an upper bound is your first unused term, but you wouldn't get why. And I like you to see it happening. Do you get why? Are we seeing why it's got to be less than 1/25th, correct? So when I come up with a window for this, I'm going to go get my guess down as a number. So go to your calculators. Let's do it both. And don't use math 0 since this is such a finite sum. Go ahead and the fourth part, if I said do S sub 10, I'd go math 0, but you're probably going to be quicker just dealing with those fractions. Let's get a fraction and a decimal output. I want the fraction because it's more accurate, but I want the decimal so you can kind of have a number that has a little more size attached to it. What's the fraction?
150 over 144.
All right, perfect. And then let's do it a decimal.
7986.
Someone said 86 though.
86.
0.79, so let's just have Golden, you read it. 0.7986, 1 repeated. Okay, I'm going to tell you that that's my guess. At most, I'm off by 1/25th. Okay, so I know the actual sum has to be somewhere between, right? My guess going up my maximum error, and it's actually just my guess on the bottom, but the theorem will say, that the fourth partial sum, you go up, you go down. We'll refine that window in just a second. I have it with fractions just because that's exact. But let's go get some decimal stuff to it. So if I could have two of you, Golden, you're pretty fast on your calculator. If you could give me the lower one, and Kaya, you got your calculator out. If you can give me the upper one, let's go out. I know you're conditioned to go to 3 decimal places, but I want to take it a little farther for these. They usually sometimes end up repeating. Let's go to. So again, I'm going to take my guess, go down the most off I could be, my guess, go up, like with the TV, right? So go ahead and give me this guy. Go ahead.
0.7586.
Ones. All right, and
0.8386.
perfect. All right. I am 100% sure that the number to which the full series converges is in that window. That window might seem kind of big, but remember, this is to the 10th, so it's only 10th off. But I could easily tighten this one up. How could I make a better window? I could have done S sub 99, and then I'd probably be accurate out to a bunch of decimal places. So this is decent. Now what I want you to do right now is go to your calculator and actually do it up to, this was n squared, right? This should handle 999. And let's kind of head out there, and I want you, when you hit enter, just 1 second. They say when your hands are up, you're not thinking about anything except the question that you're about to ask. So that's why whenever you guys raise your hand while I'm talking, I say put it down for a second. Because otherwise you're just thinking about what you want to ask me. Right? Isn't that true? That's actually educational theory. I don't take it all to heart, but sometimes I do. It is. You're like, I have a question. That question's going through your head and you're not hearing a thing I'm saying. All right, so what I want you to do is your calculator should handle 999 in this case. The last one was factorial. That's why I bugged out. So you go ahead and enter it. Now I'm going to tell you, just based on number sense, I know it fell closer to this one, and I would love it if you were like, yeah, I get why. It should have been closer to the upper bound. Why? Because that first one was a plus, and then I'm subtracting. So it's going to be over my guess. Are you nodding? So what I do, the rude version would be not to even go down on this one, but to refine it to this. But that's not what the theorem says. can you go just do the 1.79? It's right here. This is actually, I just tightened up the window quite a bit just by knowing the next one was a plus. So on the next page, you might be asking me, and again, you only have 2.5 to do, so you'll finish in class. This is what I just told you with the TV and that last example. All right? So you'll notice that the actual remainder theorem says go down and then go up. But I told you, you can actually refine that if you know whether the first unused term is positive or negative. I won't make you, though. And College Board won't either. If they ask you for it, you can just go ahead. Now let's talk about what this all means. First of all, this is only for alternating series, which means your limit as you go to infinity has to equal 0, correct? It has to be a decreasing sequence, which we can see 1 over n factorial is going to decrease, so that's usually not a big deal. What is this notation for? You should know that. The remainder, what do I call it? The rest of it, or the, which is called my, no, which is also how far off I am, which, thank you. Wow, multiple game shows. Who's the dumbest today? No, just kidding. All right. There we go. Okay, so that's actually my error. If I knew what it was, if I actually knew the sum and subtracted my guess and did the absolute value, like for yours, you know, we got it down to $10 in absolute value, but we didn't know if it was going up 10 or down 10 from his last guess. But this is the exact error, which we can't get, right? So what we do is we say it's always going to be less than or equal to, what's my words for that? The first unused term in the partial sum. Now let's try one. Because this is a really difficult question, but if you get what you're doing, like if you get what this is asking you for, this is approximated. I don't know what it is, but I'm 100% sure it converges, correct? And it's an alternating series. So the alternating series remainder theorem says approximate using a finite number of terms. This is S sub 6 in the notation, correct? The actual sum is S. Their difference in absolute value is the error, which we're going to call R sub 6, but we're going to bound it by our first unused term, which a text would call A sub 7. You see what I mean? So I'm trying, you guys are awesome. So let's go write this guy out for a while. It's going to start on a positive note. It'd be 1 over 1. Minus 1 over 2 factorial plus 1 over 3 factorial minus 1 over 4 factorial. I'm just multiplying the denominator by the next consecutive integer. 24 times 5 is 120. 120 times 6 is 720, and then I don't know, so I'm going to cheat and go 7 factorial. Yeah, I don't even care. I don't even care anymore, so I'll just do that. And then minus da 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 da. Okay, so I have no clue. I know it's going to converge. It's going to converge fast. Go do 1 divided by 9 factorial on your calculator. That's what this term is contributing. 1 divided by 9 factorial is what this term is contributing to the aggregate sum. So 0.000027 is all that one's contributing. Eventually, they're contributing what? Remember, I'm not even at, yeah, it's nothing. All right, so it says the first 6 terms. Term 1, term 2, 3, 4, 5, 6. Whether my count started with a 0, a 1, a 2, or 3, it's the first number of terms. That right there is S sub 6. I need to know it because it's my guess. So if I were you, I would go to the original. You don't even have to be in sequence mode to use math 0. It's just if you're not, this will say X equals. Right? So go ahead and math 0 and get me, can we just go decimal? Actually, I like the fraction and the decimal since I'm only doing a couple of them. So go get me S sub 6 using math 0, and that's my guess for the price of the TV. Can I get a backer on that? All right, perfect. 91 over 144. Let's approximate that with a good long decimal. Thank you so much. Do I have a backer on that though too? Okay, there we go. That's my guess. It's off. Now, do you think mine guess needs to go up to be the actual sum or down? It need only go up because I know the first missing term is a plus, but when you write your window, just go up, go down, because that's what the theorem says, but you could actually tighten that up a little bit if you really get it. However, I need to find, again, my upper bound for all this stuff I missed. It's always going to be less than or equal to the absolute value of the first. So my error, which is called R sub 6, which is actually the exact difference. And again, I'm putting this notation down so you kind of get, if they ask you for this, I want you to know they're asking you for error. If they ask you for this, I want you to know they're asking for error. If they say error, what do I want you to know? Error, right? So that's a weird word. Error is a weird word. Oh, wow. What's that called in English, what I just said, where they're really close in vowel sounds? Assonation, no, assonance? Assonance. Yeah, error is a weird word. Like they all are. Isn't that what it's called? Assonance? Did you Google it for me? Or you just know? They don't rhyme, but they're like. Yes, that one. Anyway. We got to finish up just in case people are listening to this. Otherwise, I'll let it go. All right, let's wrap this one up. So, what do I know about this error? I have no clue. I just know that I'm able to bind it by the most off I could possibly be and no more is the plus 1/7 over factorial, because then I'm just subtracting stuff all the way on out. All right, so it's less than or equal to the absolute value technically, but it is. We ended on a positive note there. So now you have to understand that this isn't much at all. Correct? So I'm going to have a very tight viewing window. My actual sum, I am confident that it must fall in 100% confidence in this interval. I go up that and down that from what? And by that I mean this. Yeah, the S sub 6. So if I were to keep it exact, I'd say 91 144ths plus this for my upper bound, and then this minus this for my lower bound, but technically my lower bound, I could use just what? Awesome. But I'm not going to. I'm going to write it what the theorem says. Do you get why the theorem's written that way? Because, I mean, we're doing just such fun. But if this said 667 and then the count started at 11, and then, you know what I mean? You'd be like, well, I don't know. And so that's why. You're at least confident that if you go up that. So let's do decimal. So if somebody can do 91 144ths and then up 1 over 7 factorial. Let's do golden again. And then Kaya's working on it now. Are you going down for me already on the 91 over 144 minus? And I'll take it. Go ahead and start. 214 repeated.
2857.
Let's just go 3. I like to take these errors out quite a bit because I don't think I'm going to have much. Why do I say that?
1 over 7
Factorial is just a killer. So what's going here? It's going to be 0.63. Did it hang in there for the third decimal place?
6317.
Ooh. So it almost hung in there, right? That's a really tight viewing window. Wouldn't you agree? Now, if we went back to the original one, and it's factorial, so I guess we probably couldn't go back past 50, and hit enter, do you think it's going to fall closer to the lower boundary or the upper boundary? Yes. The lower one actually could just be this. What do you think? This is hard stuff. Like somebody walking in right now would go, what the heck's going on up there? Look at it objectively, right? Right, Eli? Like objectively, it looks hard. So the last one, and again, I'm spending a lot of time going through very few. This is a little different. It's a different type of question, and you have to be able to go with the flow because you understand what you're doing, not that you're like doing monkey see, monkey do. So watch what I'm in search of. I'm going to give an approximation. So I'm looking for S sub what? That's my guess. I want to make sure my guess has an error, R sub, I don't know, correct? That is less than or equal to What? 1 over 1,000, which means the absolute value of my first unused term, my foot. Huh, that's new. I've never called it that before. You what? My foot. No. I just don't want to write it down. They would not accept that. I'd be going, what is going on? All right. They won't accept anything that I just wrote. I'm just trying to sort it out for you. Okay, so what do I need to do? It's basically by brute force. I need to start seeing my series. All right, so I'm going to start. What is S? No idea, but if I had an infinite lifespan, I could keep writing it out and get it. But I don't. But I'm going to start with 1 over 1 to the 4th. Then I'll do 1 over 2 to the 4th. Then I'll do 1, oops, and I forgot my alternator. That's actually a big one. Plus 1 over 3, it happens a lot. 4 to the 4th. Plus 1 over 5 to the 4th. I'm going to see, because I had this already last hour, I kind of know which one it is, so I'm going to kind of let you guys guide it instead of me saying. Okay? I need to, by brute force, figure this out. I need the first unused term, right, to be less than 1 over 1,000, and then my guess will be the partial sum leading up to it. So where do you want to hop in? 10? Okay, go do 1 over 10 to the 4th. That was a very poor guess, because that's 1/10,000th. No! 10 is way too high. It's off by at most. No, just kidding. What do you want to try?
6, because 5 is 6.5.
Yeah, see, now we're using some common sense. This, it might be 6, but I know it's not this one. So this one, let's see if this exceeds 1 over 1,000. What is it, though, decimally? 0, 0. 1 divided by 6 to the 4th.
0.0007.
Also 8, because then it goes 7, 8, if I remember right from last hour. So what is my guess going to be so that I'm confident I'm within F sub 5? 1, 2, 3, 4, 5. These, I want my first unused term to be less than. And my guess then is everything that got truncated leading up to it. So my guess is the sum of these, which I don't know what it is. We're done. So you still have like 15 minutes, and it's plenty of time to wrap up 10, 11, and 12. I have the answer to number 10 up here from last hour because we had a debate about it, and it was that where they were starting their count because it starts at 0, but the first number you write down is S sub 1. All right, so there's no sum of the first 0 terms. So I got to find that window I wrote. Maybe I didn't write it. That's okay, I have it here. It's not on there. Here it is. So number 10, wrap it up, it's on the back. You've already done the front end of it. All you need to do is give me a window in which it resides. So for number 10, 0.6319 repeated, comma, 0.634718 repeated is your confidence interval. That's what they call it in statistics. Yeah, it's not bad. But look at what's on the bottom. Factorial. Yeah. Just a second, I'm going to take these off.